Hi, in this video I'm going to show how to download and use Packmol, which is a software for generating input structures for molecular dynamics. For example, you could simulate a solute solvent box, but you can generate a lot of different starting structures, mixing solvents and making interfaces, membranes, and a lot of things. I think it's a very interesting software. Here's the web page for Packmol. This is the downloads tab. You can search it in Google. It will appear easily. So in the download, it says that basically there are several ways, but the easiest way is to use a Julia wrapper. So for this, you already need to have an editor such as VSCode and have installed Julia, which is a very powerful programming language, which I have started to use more and more lately. In Julia, you need to use the package manager. You basically write import pkg and then pkg.add and you put packmol. There's another way that is more specific for the version. So for me, using this by itself did not add the correct version of Packmol. So I will show you what you have to do instead. And then you run Packmol by entering Julia, and inside the REPL, which is basically where you interactively work with Julia, you just put using Packmol, so it will be loaded, and then you can run Packmol as a graphical interface, which is just a dialog box for opening, for searching for the file. You need a few input files. So I will show you how this is done. I will clear everything, and then I will start Julia again. So here I am inside the program, and if I write using Packmol, this should work because I have already downloaded. If it doesn't, you need to put this thing. So here, what I'm doing is using package.add, but I'm specifying the name of the package and the version. So I had to do this in order to get a working version for Packmol. You have to search which one is the latest one that you want to download. And after that, you write using Packmol, and then you can write this, run Packmol with parentheses, and a dialog box should open here where you can search for a file. So basically this would be interface.imp, and if I run this, it will just run, and it's relatively fast. And it took 4 seconds, and it generated this file called interface.xyz. This is an input file. I will explain a little bit the contents, that makes a box of around 4 nanometers inside, and it puts half of the box with water molecules, the other half with chloroform molecules, and it puts a hormone in between. But I want to show you how to make your own interface file for the different molecules. So I will start as usually with corolls. So I will clear this and I will open one of my files. So here you can see this structure of a coroll. And let's say I'm going to try to make a similar input file for the Packmol software, but I'm going to, instead of using a drug, a hormone, I will put one of my corolls in the interface. So first I need to save this as an XYZ file, but it's actually an Xmol file. So you need to choose Xmol format. This is the second option. And I'm going to go to the folder and I will call this coroll.xyz. So now I'll go back to Julia. Actually, this is VSCode. Okay, so here in my folder, I have several files. Unfortunately, I don't know how to increase the font size of the Explorer bar, but basically I have the interface.imp file. So I'm going to copy it and save it with a different name. So now we have a new input file for Packmol. So this is now a coroll in an interface of water and carbon tetrachloride. So basically, I'm going to change this, the name for the T3, which is the hormone. I'm going to call it coroll. In this file, there's a box. The box goes in the X direction from -20 to 21 angstrom, and the y and z directions, it goes from 0 to 39. So basically putting x equals 0 is going to be the middle of the x values, and y and z equal 20 is going to be the middle of the y and z directions. And this is a rotation angle. Basically, this is pi over 2, but I'm going to have to figure it out for the particular corole. And then I'm using the chlor.xyz file for chloroform. These are coordinates that were already predefined in a file, and water.xyz for water. And what I'm saying is that I'm putting 1019 water molecules inside half of the box. So this means inside box, and 199 chloroform molecules in the other half of the box. So I'm not going to change these values. So if you go to chlor, it's actually carbon tetrachloride, sorry, and you have the coordinates for the carbon tetrachloride. This is an xmol kind of file. So the first line contains the number of atoms, and the other is just a name, a legend. It can be anything. It's ignored for most purposes. For water, you have the structure of water, H2O. So in the interface corole, let's see how this works. Maybe I will have to rotate the corole different angles, but let's see. So if I go to run Packmol again, and then I choose interface corole, let's see if this works. So it took a little bit longer. So I did not change the output name, so this should be interface corole. I will change it for the next run, and if I want to now open this in Chemcraft, I just go and it's going to be called interface again because I have not changed the name. So let's see, it actually looks quite good. So I will change a little bit the visualization style. I'm selecting the whole corole and display mixed. I'm going to choose so this looks good. I would have to check that there's no strange covalent bonds, but I'm guessing Packmol should take care of that. That's something it's not so easy to check in Chemcraft, but this should be fine. So let's say I want to make a different program. This is already quite interesting for starting a molecular dynamics simulation, but I'm going to clear this, and I'm going to add a fragment, and let's say I want to make acetonitrile, which is one of my favorite organic solvents here. So I'm going to center. So now I have an acetonitrile molecule. So if I go to coordinates, these are the coordinates. So I'm going to save this again as an xmol file. I'm going to call it mecn.xyz. And now here let's see how it works. I'm going to call this interface corole, and I'm going to choose mecn here. And let's say I put slightly fewer molecules. As far as I know, you have to figure this number by yourself, but maybe there's an option in Packmol to automatically see how many molecules fit in the box. So, but this seems to be okay. I will run again, run Packmol, choose the input file. And now I'm going to open the XYZ file. So this looks actually quite good. All molecules seem to be inside the box. So if I look at some of the outer lying molecules, basically, yes, they are all inside the box. Maybe I have room for more molecules. So this is actually quite interesting because doing molecular dynamics with this kind of system can be done even in Orca or XTB using the GFN2FF force field or using multi-level schemes, it's not going to take that long, and you can actually see some chemistry happening, at least some, let's say, partition characteristics of a molecule. I want to see if I can actually mix the molecules. Let's see what happens if I choose the same boundaries for all molecules. So I'm going to go again to the input file. I'm going to copy this, paste. So rename, this is going to be, I will call it Corol MECN water H2O mixture, mix. And I'm going to say use the same as output. So here the output file is going to have the same name. So basically what I'm going to do is to allow water and acetonitrile to go in the same box. I think this should be 21 and this should be minus 20. So I'm choosing the whole range of X, Y, and Z values for both solvents, and I'm keeping the Corol in the middle. So let's see what happens. I'm not changing the number of water or acetonitrile molecules because I'm assuming the density is going to be more or less the same if they mix, but I think some trial and error should be done. So let's run it again. So this would be Corol acetonitrile water mix. Let's see. Hopefully it will not crash or anything. If I go look at the output, nice, nice. This is really nice because I can make the mixture. So this is all for now. I hope you have found this useful. I'm certainly very eager to explore the possibilities of Packmol. I knew software like this existed, but I actually didn't know Packmol before last week, so I have been playing around a little bit with this. I think it's quite powerful if you want to make systematic molecular dynamic studies of actually whatever kind of molecule you want, proteins, membranes, anything. So thank you very much.